marine science presentation. I'm Abby McInerney and I'm from Austin, Texas.
I'm Hanna and I'm from Islesboro, Maine.
And my name is Grace Keller-Long and I'm from St. Paul, Minnesota.
Together, we make up the fellowship with the Carcinus, and we will be presenting our project on invasive crabs on the coast of Maine.
An invasive species is a species that is outside of its native range and harmfully affecting the ecosystem it has invaded. In our project, we focus on two species of invasive crabs, green crabs and Asian shore crabs. Green crabs were introduced to New England in 1817 and came to Maine in the early 1900s. They primarily affected the native populations of soft-shelled clams. They have been named one of the 100 most successful invasive species in the world.
Asian shore crabs first appeared in New England more recently, in 1988, and progressed up to Maine in 2001. These crabs have several qualities that allow them to be extremely successful as invasive species, such as a breeding season that is twice as long as the native crabs, and larvae that remain in the water for a month to allow for maximum dispersal. Both species of crabs are affected by parasites in their native range, but not on the coast of Maine, which allows for a greater abundance of these invasive crabs.
These invasive crabs are known to be adapted to a variety of different environments. So we decided to choose 4 locations to study with this in mind. We selected 2 different marshy estuarine locations, Warden Point, it'll go. Okay, it's not moving. Okay, that just, okay. It's okay. Those are the Warden Point and Broad Cove, 1 rocky intertidal site, Harpswell, and a combination of rocky intertidal and marsh recompense campground.
The purpose of our experiment was to study the impact of invasive species on the ecosystems they invade. We also want to study the distribution patterns of invasive crabs after the spring thaw, when they are moving from deeper coastal water towards the shore. We hypothesized that a greater abundance of crabs would lead to lower overall biodiversity on location.
So first we conducted a biodiversity survey with quadrats and transects in each location. We set out transects, which are lines that run perpendicular to the shore, and placed half-meter squares, or quadrats, at 5-meter intervals along the transects. Within each quadrat, we counted the number of species, as well as the number of individuals in each species, in order to calculate biodiversity. We also set out crab traps, but did not catch any crabs. So we searched for the crabs by hand, with an equal amount of time and people in each location, 7 people for 30 minutes.
We then brought the crabs back to the lab, where we sectioned them and measured their width of their carapace with a caliper.
We collected a total of 177 crabs at Harpswell, which has a rocky intertidal environment. We found 9 crabs at Recompense, which is both rocky intertidal and estuarine. We saw no crabs in the estuarine environments of Warden Point and Broad Cove. We also found no female green crabs at any of the locations.
So this graph shows the size distribution of the various crabs that we collected, with different colors indicating different locations and species. We observed that except for 1 green crab outlier, the size distributions of the crabs at Harpswell were clustered in the same region, between 8 millimeters and 22 millimeters. However, the size distributions of the crabs at Recompense had a very marked divide. The green crabs were between 4 millimeters and 16 millimeters, while the Asian shore crabs are in a completely different part of the graph, measuring between 22 and 28 millimeters.
This graph shows the average biodiversity by location. As you can see, we observed the highest biodiversity at Harpswell and the lowest at Warden Point. In this graph, we plotted the biodiversity of each location on the x-axis against the number of crabs we found on the y-axis, in order to see if there was a correlation between crab abundance and biodiversity. We did not observe any correlation between the two. In fact, the location with the highest biodiversity also had the most crabs. However, our data only reflects the populations during spring, and there may be a greater abundances of crabs at other times of the year, which could contribute to the trends that we saw.
This graph shows the abundance of crabs that we found by location. As you can see, there were many more crabs at Harpswell than any other place. This may be because crabs returning to the shore after spending the winter in deeper water would return to this area of the shore faster, since it is closer to the open ocean than any of the other locations we surveyed.
Asian shore crabs are relatively new to the coast of Maine. It is interesting to track how they interact with the previously established green crabs. We found many more Asian shore crabs than green crabs, and this could be due to the fact that Asian shore crabs eat a variety of species that green crabs do not, including echinoderms, barnacles, and even green crabs. Also, the past 2 winters have been abnormally cold, contributing to the decline in green crab population. Perhaps the hardier Asian shore crabs have risen to take their place.
Since we only observed male green crabs, one could conclude that this species will soon die out because they are unable to reproduce. However, if the female green crabs are still further out in the ocean at this time of year, strategic trap placements targeting one specific sex, the returning females, would allow it to control the crabs better because it would limit the reproduction. Placing traps at the entrances to marshes, which are known to be inhabited by invasive crabs, may also limit the dispersal of this invasive species. Rather than placing traps year-round, strategic trapping during transitional periods may be the best way to control these invasive species.
We would like to thank a few people for their help on this project. First, Dr. Carrie Whitaker and Laura Carson for their ongoing support and scientific expertise. We would also like to thank our fellow classmates, especially the group Acid, who assisted with crab collection, sometimes in the wee hours of the morning. We also would like to thank the 186 crabs who made this project possible, including Gandalf, the green crab outlier. Lastly, we would like to thank all of you for coming to our presentation.